All right, so there are going to be times, welcome to part 2. Sorry, this is 4.2, fractional exponents, rational exponents. Anyway, we're going to pick up right here. There are going to be often times where when we have a fractional exponent, we're not going to have a numerator that's 1. It's not going to be 1 over 2, 1 over 3, 1 over 4, something like that. Our numerator is going to be some other number than 1. In that case, what we're actually going to be doing here is we're going to be splitting our fraction into 2 parts. So for instance, if we had a fraction like this, like 3 over 2, we can split that into 3 times 1/2. Let's take a look at what that would look like for a particular number. So let's say we had an exponent of 3 over 2 here. Here we go. We can split this up. So rather than being 3 over 2, we can split that up using multiplication. This can be 4 to the 3 times 1/2. Okay, and then further, right, we can actually evaluate this. We can split this up. This is the product property. So what this is the same thing as is 4 to the 3rd to the 1/2 power. Now I can start thinking about what this is actually equal to, right? I can actually start to perform some calculations here. 4 to the 3rd power is 4 times 4 times 4, 64. So it's 64 to the 1/2 power. Remember, an exponent of 1/2, that's just square root. So this is the same thing as the square root of 64, which is equal to 8. Just a little bit more, that equals 8. I won't necessarily go through this full example here on the rest of these. We'll just talk about basically splitting up the numbers. As an alternative, I could have done this in a slightly different manner, so I'll go ahead and talk about that, right? Rather than doing it as 3 times 1/2, right? The order of multiplication can move around, so we could write it out the other way. So this could be the same thing as doing it as 4 to the 1/2 to the 3rd. We can switch the order of that, right? The order of the multiplication is not important. And in that case, we would take the square root of 4, and then we'd be raising that to the 3rd power. Kind of cool there. That's actually a little bit simpler because taking the square root is actually going to make the number smaller first, and then we'll cube it. So the square root of 4 is 2. 2 cubed, we get the same thing. We get the answer of 8, right? These are equal. They're equivalent because it doesn't matter. The order of multiplication can be switched around in this case. Again, I won't be showing how the exponent stuff works for the rest of these, but I'll go ahead and talk about the fraction, splitting up the fraction. All right, so here we go. Fraction of 4/3, right? That can split up into 4, which is our numerator, times 1/3. Or we can reverse that order. It could be 1/3 times 4. And depending on, the problem that we're using, the specific number that we may be using this exponent with, if this is indeed an exponent, it might be easier to think about it in one way or the other. And then finally, this fraction here, 5 over 7, again, it could be split up as 5 times 1/7 or 1/7 times 5. And one of those ways may make more sense to us in the context of using this as an exponent. So we'll make sure to think about that and know that we can do it both ways as we're using this process to sort of simplify some of these exponent problems. Go to move forward. Here's how this works with exponents. We already kind of looked at this exact problem on the other side. Remember, it was equal to 8. Notice that it works in both directions, sort of just like we showed. But we'll go ahead and go through some more here. If you weren't quite sure and you need to check in here, feel free to pause and kind of look through this. But I'm going to be moving forward. Right, shows how both of them actually end up being equivalent to 8. Here is a kind of a way of writing it or a way of thinking about it as a rule. Anytime we have a fractional exponent of m over n, m is the numerator, n is the denominator. We can rewrite that as the nth root of b to the m. So the n is the denominator, the m is the numerator in this case. Or we can switch that order around. We can do the nth root and then raise that to the m power. Notice that the order of operations here is slightly different, but they're actually going to be equivalent and it doesn't matter. So both of them work. B to the m over n, right? It can be done 2 different ways. it can be done as the nth root of b to the m, or it may be easier to think about it in another way where we do the nth root of b and then raise that to the m power. Both of these things are valid and they're equivalent to each other. These two things are equal. It doesn't matter which way you do it. Just one method may be easier. Depends. All right, let's go ahead and run through that. Again, I'll try to write this up here again just so we can keep track of that. So and I'll try to show at least a couple of them in a couple different ways here. All right, so we have 16 to the 3/4 power. Yeah, 16 to the 3/4. So the numerator is 3, the denominator is 4. So we're going to be taking the 4th root. That's going to be the type of root that we're going to be using. And we're going to be raising to the 3rd power. That's the exponent that we're going to be giving stuff. And again, we can do it both ways. Let's write that out. So it's either the 4th root of 16 to the 3rd. We'll talk about why that may be difficult in just a second. Or it could be the 4th root of 16 all raised to the 3rd power. These are equal to each other. It doesn't matter which way you do it, though one of them is going to have some benefits. The problem we have with this first option is 16 to the 3rd power is a really large number. That's 16 times 16 times 16. Let's just do that real quick. 16 to the 3rd power. 4,096, right? If I'm going to be trying to do this without a calculator, that's a really big number to be working with. I'm going to go ahead and write it out because it is true, but I may not want to be working with a number quite this large. And now I need to know what the 4th root of 4,096 is. I don't know. I don't know what the 4th root of this number is. This is huge. I can use my calculator, but again, I may not want to be using my calculator to rely on this. So again, this is why this order for this particular problem is not that great. Well, turns out it's 8. If we do 8 times 8 times 8 times 8, it's the same thing as 4,096, or 8 to the 4th, right? So this is equal to 8. But again, it's not great. I didn't like the way that worked out. It's a little bit easier to go this other way. Right? Notice we're going to evaluate what's in the parentheses first. So we're going to do the 4th root of 16. What number multiplies by itself 4 times to get 16? That's 2. I can check that real quick. 2 times 2 times 2 times 2. 4 of them gives us 16. So the 4th root is 2. And now we're going to be raising that number to the 3rd power. We're dealing with a much smaller number than 4,096. It's not too bad, but we do get the same answer, right? We get 8 either way. Oftentimes, it will be a little bit easier to write your answers in this manner, right? Which is this one over here, but it won't always be the best. So you got to keep in mind both paths here. Let's go ahead and do this next one. We have 25 to the 3/2 power. Again, the denominator, that's what type of root we're taking. So it's a 2, so we're taking the square root of 25. Notice square root doesn't have this little number here. If it did, right, there'd be a 2. It'd be what number squared gives us this. But we often don't write that, so you don't have to. And then we'll raise that to the 3rd power. Square root of 25, we probably all know what that is. It's 5. 5 to the 3rd power, that's 5 times 5 times 5. We end up with 125. There we go. This was 8. Again, this one would have been a little bit trickier, right? If we raise it to the 3rd power first, we're dealing with 25 cubed. That's huge. That's going to be even bigger than this. So I like this method better. Last one on this page here, 8 to the -2/3. Remember, with negative exponents, we often want to write that as a positive version. So we'll write it as 1/8 to the 2/3. And now we'll start simplifying. We'll deal with this fractional exponent. So we're going to be taking the cube root of 8, and then we'll be squaring it, right? Cube root, because that's the denominator of the fraction, the fractional exponent, and squared because 2 is the numerator of our fractional exponent. And then we can start simplifying this. The cube root of 8 is 2, so this becomes 1 over 2 squared. 2 squared is 4, so we get 1 over 4. Now, all of this can be done using our calculator. I don't want you to rely on the calculator. I want you to be able to do this without. But if you really want to check something like this, you can do 8, then press this exponent button here, and we will need to be putting in a fraction. So that ABC button gives us a fraction as our exponent, and we did -2 over 3, right? And it should calculate that out. It gave us a decimal version, but that decimal is equivalent to 1 over 4, right? 1 divided by 4 is the same thing as that. So fractional version preferred, but so for other numbers, let's just double check all of these. So 25 to the fraction 3 over 2. Got 125 confirmed, and then 16 to the 3 over 4. Oops. Then too many fractions there. 3 over 4. We got 8. Yep, 8. A lot of this stuff can be done using the calculator, but I really want you to understand what's going on and how these fractional exponents relate to roots and powers and how we can use that to simplify things down as well. All right, and that's it for part 2. And go ahead and try the homework problems, guys.